So in this second video, let's just shortly pick up where we left off with the last picture, and just suppose we thought that the radius were 2 plus or minus 0.01. Let's approximate the possible error in the function value f of x equals x cubed. Remember, this could have been like computing the volume, 4/3 pi r cubed, but we just cut off the 4/3 pi to keep the calculations a little easier. So, if x were between here and here, the function value is going to be between here and here, roughly, right? About right in there. Now, the function may change different up here than it would down here, but the tangent line won't change differently. The tangent line will have the same little dy here for a run dx here as it will a run dx here and a rise negative dy down there, right? The rise there for a run there is the same as the rise there for a run there in terms of the tangent line, but not along the function. So that's why we can play this game where we can go x plus or minus some bit here, because the tangent line is going to change the same on the upside as it will on the downside for the plus and minus little delta x right here. So once we got that out of the way, then, suppose we thought that the radius were 2 plus or minus 0.01, approximate the error in applying, in computing the function value, f of x equals x cubed. So now we'd have the f of x plus delta x down here, up there, and the f of x minus delta x would be down here. I don't think it's necessary to sketch it all in there. Like we've already said, the function could change differently up there as it does down there, but the tangent line will change the same. So, like I told you on these things, then, you need a f, you need an x, you need a delta x. So, we've got our f, we've got our x, and our delta x, is plus or minus 0.01. Well, remember now, that delta x is creating a dy, right? The delta x, which is dx, creates a dy, and that dy that we're going to be using, it's just, it's either plus that much or minus that much. So you could really think of it like this is a plus or minus dy, that little approximate error. It's like plus or minus that dy. But, I don't think it's necessary to put the actual plus or minus in there when you're doing the calculations, just so long as you remember that at the end when you're talking about the error. So that's what we could do then. We'll use this little f of x plus delta x guy that we formulated in the first video, and we've got our f, we've got our x, and we've got our delta x. So we stick in there, we've got f of x plus delta x approximately equals f of x plus f prime of x delta x. I put in my x, I put in my delta x. See, I just put in my x, right? And I just put in my delta x. It's that easy. Now, what is the function f doing? Well, f is a cubing function, so this, 2 plus 0.01, this is the 2.01 cubed, right? That's the 2.01 cubed, approximately equals f, f of 2. Well, f of 2 is going to be 2 cubed. F prime of 2, we're going to need f prime right here. Get our f prime of x. So when we talk about right here f prime of 2, we're talking about 3 times 2 squared, right? So there's my f prime of 2, delta x. So this little bit here, like we said, this little bit hanging off the tail, this is the approximate error right here, this 0.12. So when x goes plus or minus 0.01, then the volume is going plus or minus 0.12 approximately. Right? The volume is going plus or minus 0.12 approximately. Even though the function is changing something else, the tangent line is changing by 0.12 to the upside, 0.12 to the downside, right? As x changes, as x is between plus or minus 0.01, the tangent line is going plus or minus 0.12. That's what this is. Hopefully convincing you of.